Hi, I'm an old guy and I do maths. And today we're going to do a simple equation using log tables, and you're going to be treated to a little bit of history. So let's start with the history. Um, I suppose my attending school now qualifies as history. It was so long ago. And when I did, we used log tables. We didn't have calculators, we used log tables. And all of these tables were in base 10. So for instance, 10 to the power of 0, that's the logarithm, the power equals 1. And these log tables ran from 1 through to 9.999 all the way across in this bottom corner of this page. And what we did was we harnessed the power of a logarithm to make what might be a complicated multiplication into something that simply required addition. And the person behind all of this is a guy called John Napier, who was around in the time of Shakespeare. I think he died in the early 1600s. And he was a Scottish landowner and mathematician and all-round sort of brilliant guy. And it was his idea um, to harness these and popularize these. Um, um, did he discover them? Were they out there somewhere and nobody had noticed? Who really knows when it comes to mathematics? But um, he's the man behind them, and he's behind the popularity of the decimal point, which was a kind of arcane thing up until then. But you don't want to be doing these with fractions. You want to be doing these with decimals. Therefore, the decimal point comes into vogue. Now, how do they work? Well, we take a simple multiplication like this. 6 times 3 is 18, and what we do is we find the two numbers. We find the log for 6, which is here, 0.7782, and put that there. And we find the number for 3, which is 0.4771. Now these are four-digit logarithms, so there's a little bit of rounding involved, as we will see when we come to the answer. And we don't have to multiply these, because what we have is we have 2 powers of 10. It's as if we have this 10 to the power of 0.7782 times 10 to the power of 0.4771, and that's going to equal something. In fact, it should equal 18 or very close to it. But because the bases are the same, we just add these two, and then we have to decode them. I'm going to decode them using the logarithm page rather than getting into anti-logarithms, because this is more of a demonstration than anything, and I'm going to show you this on the calculator as well. Okay, well, what do? Well, we add these, and we get 1.2553. This is the thing we're interested in, this part here, because this is 10 to the power of 1, which will give us 10, and this is the rest. So let's have a look in the log tables. What are we looking for? Well, we know that we want our answer to be 18. Note that this runs from 1 to 10, so 18 is not in here, but 1.8 is. It's there. And there's our number, 0.2553. So, what's with this? Well, what that does is it takes it from being 1.8 to being 10 to the power of 1.2553. That's what we got in the tables, but that's what we got when we did the addition. So this moves it up one order. And what that is, it is 1.8 times 10 to the power of 1 which is 18. As it turns out, there wasn't really a rounding error. Now, let me show you this on my calculator. So how it works out on my calculator is like this. The log button on here is in base 10, so log of 6 plus log of 3 is 1.255 and a whole pile of numbers. When I raise 10 to that power, 1.2553 let's call it, I get 18. That's how this works. Now, I'm not going to do a division, but I'll explain how it's done. You subtract. There you are. It's that simple. And from this unpromising beginning in early high school comes all knowledge that there is, in my head anyway, of logarithms. This is how we were introduced to them. Now, I hope you found that interesting and perhaps useful, and it may have cleared up a couple of things for you about logarithms. By the way, I should just complete that. Yeah, I hope it cleared up one or two things about logarithms. It's, I think, a good way to start dealing in base 10. It makes it more understandable. Anyway, thank you very much for watching. Don't forget to like and subscribe, and I'll see you next time. Bye.